In this next series of videos, we're going to be talking about the theory part of databases. Now, a lot of this theory is really dry and boring, and to be honest, I don't cover all that much of it. Many other classes focus the entirety of their databases class on just this part. Instead, I'm going to be teaching you basically the bare minimum you need to know in order to be effective with designing your databases. So why is this important to actually talk about database design? Well, it's because different databases structures, like having one huge table versus many small tables versus some tables that share data and some tables that don't, has a huge impact on both the performance of the database as well as countering potential problems that you could have with your database in terms of inconsistent data. So in order to talk about a lot of this, we're going to have to talk a little bit about how do you visually represent the structure of your database, and then later on we'll be talking about, well, how do you design good structures for your database such that you get very performant usage, as well as avoiding some of these sorts of problems that I'm going to be talking about in later videos. So to start off with, we're going to be talking about entity relationship diagrams, and they look something like this. There's a lot of diamonds, squares, and ovals that represent different parts of your model, different parts of your system that you're trying to represent within a particular database. Now, I don't expect this to make any sense right now, but we're going to go through it piece by piece. So the purpose of what's called an entity relation model, or sometimes I'll just abbreviate it as an ER model, is that they roughly describe the system that we care about. And sometimes if our system is very complicated, if there's a lot of different parts of it and a lot of structure in it, it becomes a very complicated diagram. Sometimes these diagrams are much simpler as well. And so these models also show some of the constraints we want to capture. Like, for instance, and we'll show a lot of those constraints in a little bit. And I just want to tell, this is always the kind of like, why do we care part of the class? And so it seems kind of silly to begin with, but when you start having to work with more complex systems, these sorts of tools become necessary in order to get any work done. And so I just want to remind everybody that it's really difficult to have a database that works well, that's efficient, that's easy to use, if you don't design it well to begin with, and that's why we're talking about this in this video. Okay, so in this ER model, the first thing we're going to talk about is the E part, the entity. This is the thing or the object that you're trying to store information about. And what you have is the entity itself might be like a species, and then you have the entity set, which are a collection of similar entities that are related to that. Now, once again, with examples, this should make a bit more sense. Entities can have attributes. These are properties. These are things that each entity has information regarding. And one really important thing that's an easy mistake to begin with is that attributes should be simple types. So they should be things like integers or strings or booleans, things like that. You shouldn't have attributes that are collections. So no attribute should be a list or a struct or a set. If you have something that should be a collection, it probably should be an entity into itself. All right, once again, this won't make a lot of sense until we get to some examples, but I got to establish the vocabulary first. Okay, so when you're trying to draw entities and attributes in a entity relationship diagram, the entity set is represented with a rectangle, and attributes are represented with an oval with a little line connecting the oval to the rectangle to say what is it part of, what entity is it a member of. And so here we have a species, and I'm going to be just running with an example of Pokemon. And if you don't know about Pokemon, it's not a big deal. But in Pokemon, there's different species like Pikachu, which has a particular type like electric and a name like Pikachu. And so one thing I want to make it really clear here, because we're going to be using these diagrams a fair bit, is the entity is species, the thing in the rectangle, and type and name are attributes. And every entity in species, so every example of a species, must have a type and a name. So Pikachu has a name Pikachu, and it has a type electric. You could also have Dragini, which is type dragon or ice, or I can't remember off the top of my head, and its name is Dragini, and so forth. All right, so that's the E part of entity relationship diagrams. The other side is relationships. Relationships connect two or more entity sets. They're connected by lines again, and the name of the relationship is inside of a diamond. And so here I'm saying there is an entity called species, which like Pikachu, and there's entities like Pokemon, which would be like a very specific Pokemon, like my Rattata is named Jake. and it has a particular level, it has a name, and it has a status effect. And what I'm saying here with this instance of is Jake is an instance of species. Jake has a particular relationship with some entity, saying Jake is a Rattata. So it's connecting that information regarding Rattata, and it's connecting the information regarding Jake together through this relationship. Okay, so let's talk about a bit more of that. So when you talk about values, like actual data in your database, you can think of these as particular entries in an entity set. So let's say we have some data here. We have Pokemon, which have names, levels, and statuses, and you have species, which have a name and a type. And so what this is saying is, the Pokemon named ATV has a particular level, 29. Its status is paralyzed, and in the species, we also have things like Venomoth and Poison. Now, these are, once again, values of entity sets. These are values of the entities themselves. If I want to say, hey, ATV is a Venomoth, we need to add another bit of information here. So relationship sets, those connections between entities, those relationships, are also have data associated with them. So for instance, our instance of from previously, we have a Pokemon like ATV and a species like Venomoth, so that you can connect the information regarding the Pokemon and the information regarding the species together. Okay, so we've been showing, all of one relationship, but you can also have relationships that are multi-way. So for instance, let's say we have a relationship called a battle, where we have a Pokemon battle between multiple trainers, multiple Pokemon involved, and music that's involved, because you can't have Pokemon without that good battle music. And so what happens here is we're saying, okay, for every particular battle relationship, every time there's some occurrence occurs of a battle, there will be trainers involved, and those trainers have names. There will be Pokemon involved, and those Pokemon have levels, names, and statuses. And there will be music involved, and each music has a theme. And so you can have relationships that are multi-way, that are more than just between two things. Okay, the other important thing to talk about relationships is their multiplicity. This has to do with, for each entity, how many relations can it be involved in? The simplest example is that of the one-to-one relationship. So in this example, each species has at most one cry, and each cry, this is the noise the species makes, has at most one species. And so what this is saying is, okay, Pikachu has a particular cry, Rattata has a particular cry. If I can, each cry is unique to a given species, but this doesn't say necessarily that every species must have a cry. It can have 0 cries, or can have at most 1 cry, and each cry can have 1 species or 0 species. So one-to-one is really at most 1 to at most 1. Slightly more complicated is that of the many-to-one relationship. So here is when you have, for instance, Pokemon are an instance of a species. So my Jake Pokemon is an instance of Rattata, but that is not to say that Rattata has at most 1 Pokemon associated with it. There's many different Rattatas in the game. Jake is only one of them. And so what this is saying is Jake has at most 1 species, but the species, for instance, Rattata, can have many Pokemon associated with it. That's the many-to-one relationship. And lastly, there's the many-to-many relationship, which has to do with the fact that you have a relationship where a number of one entity can be related to a number of another entity. So for instance, in the game, trainers can carry items. So for instance, I'm a trainer and I have the item Pokeball. And I also have the item Master Ball, and I also have the item Potion. But the item Potion can have many trainers associated. I have a potion, but so does Rival, and so does Professor Oak. So it's here we have a many-to-many relationship. And so we represent these different relationships by the arrows here. So the arrow points at the entity that there is one or many of. And once again, an arrow here represents a one relationship, and just a line represents the possibility of a many relationship. So this is saying, the interesting one here is the many-to-one. It's saying for each Pokemon, it can have at most 1 species, so Pokemon points to species, but each species can have many Pokemon, and you can represent the line without the arrowhead as just like a many relationship here. All right, so multiple choice question time. What is the multiplicity of character to costume here? All right, so let's go through this information here. So Harry wears a robe and Gandalf wears a robe. So this already tells us that we're not in a one-to-one relationship here, right? Because multiple characters can have the same costume. We also see that Jamie is wearing armor and Jamie is also wearing a cape. So this also tells us, hey, it's not just that each character wears one costume, but each character can wear multiple costumes and each costume can be worn by multiple characters. So what is the multiplicity here? The multiplicity is many to many here. Okay, so how do you represent multiplicity? Well, I already mentioned this a little bit, but I want to be really explicit about it. So a one-to-one relationship has arrows entering, aka pointing at both entity sets. A many-to-one relationship has an arrow entering the one side. And a many-to-many relationship just has two lines without arrowheads connecting the entity sets. However, there's another little added fun bit here, is a rounded arrow means exactly one. So each entity in the first set is related to exactly one of the target set. And unfortunately, PowerPoint doesn't give me a nice way to do rounded arrows, so I'm going to just show you what my notation is. So when I have a rounded arrow, we'll have these lines here specifying, it looks like a greater than symbol. So this is a rounded arrow here, which I'm trying to represent, which says each species must have a cry. Whereas here I have a normal arrow, which says each Pokemon can have at most one trainer. So this is the difference. Now in the first one, species must have exactly one cry. Every species has one cry. And now, because of the way I've drawn the arrows, a given cry could be associated with multiple species. And now in the lower one, the normal arrow, Pokemon can have at most one trainer. You can't have a Pokemon with multiple trainers. However, not every Pokemon must have a trainer. Some Pokemon are wild Pokemon and they don't have a trainer associated with them. Okay? So, another multiple choice question time. What is the multiplicity of trainer to catchphrase? All right, so what we have here are two rounded arrows, meaning exactly one. So this says each trainer must have exactly one catchphrase, and each catchphrase must have exactly one trainer, meaning every trainer has a given catchphrase, and each catchphrase has a given trainer. So, when you walk up to somebody in Pokemon, they say something. That something they say is unique to that maybe trainer class, at least in this model. So the correct answer here is the first one. This is an exactly one to exactly one relationship.